So, Joy, this is the third session. Let's continue the linear queue. I want you to have a look, please, here with me. Tell me what this guy is trying to do here.
He's putting in the where is the head pointer and the tail pointer,
Okay.
and also how many spaces are there for the names, which is 10.
And so this is the head pointer, and this could be the tail pointer. It depends on how many things we added inside. This is if it is full. So can you please have a look here? Can you tell me what is that? What is this doing? What this line is responsible for? This one. What is this if condition it's checking?
If it's less than 10.
Okay, what is that? What is that? Tail pointer.
Yeah.
Okay, why 10?
Because 10 is the maximum.
And from where you get this word, from where you get the 10 in the code in front of us?
From the names, because it's multiplied by 10, so it shows there's 10 space.
So if we change this to 11, where are you going to change else?
The tail pointer, which is less than 11.
So it will become 11 here.
Yeah.
Okay, good. So, okay, if the tail pointer is in that case, it's still 10, right? So if it is less than 10, it means that it is not. If it is not here, he will be able to insert. He will insert something. He will insert something inside the names array. Am I right?
Yep.
Okay. After he insert, what he going to do? What is that?
When after that they will go down the array by one more by adding the tail pointer by 1.
Okay. Why he does it?
So that it moves on to the next array, the next space.
So assume I call in queue. Assume I call. So we have an empty array like that we were having now here, and I call in queue here, and I pass it go like that. Okay. Now I want you to tell me if this is the first time we call the queue. So it means that it's empty. This is the first time that we insert something inside. Okay. I want you to tell me the values after we insert. What will be the values or the numbers inside the tail pointer and inside the head pointer from the code? So we go through the code and you tell me. Okay. So now, the first value I want you to look here first. What is the first value of the head pointer before we call the enqueue? Head pointer is -1. It's pointing not to here. It's pointing somewhere outside. It's -1. And the tail pointer is pointing to 0. This is a totally empty queue. Okay. So now we call enqueue with JO. Right. So that is just the definitions. Now let us have a look here. The tail pointer is less than 10 or bigger than 10?
Less than 10.
Why? How much is the tail pointer now?
It's 0.
Perfect. Good. So we will run here. Okay. So I want you to tell me where inside the array names here you're going to insert Joe. From the bottom or from the top?
From the bottom.
Okay, from the bottom. Based on what from the bottom? Based on the value of the tail pointer, right? Because this is an array. And the tail pointer is actually the one who decides where you want to insert. What is the value of the tail pointer now?
It will be 1 now.
No. Why is it 1? It started with 0.
Started with 0. It'll still be 0.
It'll still be 0, right? So it
Yeah.
will be 0 here, right? So it means that
Yeah.
we come here, we put JO. Okay? After this,
Then you will add the tail pointer by 1.
so
So
now
you
tail
move
pointer will become 1, right? So it will
Yeah.
move. It will move from here. So now tail pointer will be pointing to where? Here, right?
Yeah.
Tell me.
It will be 1, right? Oh, 0.
Okay. Yeah, you're correct. Yes, yes, yeah, you're correct. It should be 1, yes. It should be here, yes. Okay, and then what about the head pointer? What is the value of the head pointer now?
It's out of the array -1.
Okay, and then what we will do with that if statement? How it's going to run?
If it's still at -1, then change it to 0, which is by moving down the array by 1.
So it means that now the head pointer will be pointing here, right?
Yeah.
Okay, but what is the point of putting the tail pointer to point to an empty place here? Why? Why he do that?
So the next time you put in the data, it will save into an empty slot.
Perfect. Okay, now you understand. Now you understand. So now you are able to go to your code and fix the exercise. Okay?
Okay.
Now we move to the next. We move to the next here. Okay, now we have the same array, and that same array only, and that same queue only have one entry inside is called Joe, like that. And here from previously we have head pointer here, and where we have the tail pointer?
Still at 0.
Tail pointer.
Also 0.
Wait, tail pointer we incremented by 1, right? What was the initial? So
Initially was 0.
and when we incremented by 1, it's pointing to where?
1.
Okay, so here we have the tail pointer. So DQ, it means that we have to take something out of the queue, right? So can we tell me please, what about now from the values that we are having here, what this if statement will do?
If the head pointer is still out of the array, that means -1, then it'll print that the queue is empty. There's no data in the queue.
Okay, what is the case now? This will run or no?
It won't run because the head pointer is at 0.
Okay, then we move to the else, right? So
Yeah.
what is this lines going to do?
Else the added item will be added to the position of the head pointer.
No.
And then
Wait first. Wait. What is this going to do?
it will print whatever data that is in the head pointer will be pointing to the which array they will be pointing to, and then they'll print the item in it.
What is in our case? What is going to print?
JO.
Okay. And what will happen to the head pointer after that?
They will add by another one, so we move down the array by 1.
So it will be not here anymore, and it will move here, right?
Yeah.
Okay. Now what is that condition?
Now, if the head pointer is at the position of the tail pointer, which is the case now, the head pointer will reset to -1 and the tail pointer reset to 0.
And why we need to do that?
So that the next time a user goes down the array to NQ or DQ a value, it won't mess up the flow.
Okay, that's okay. That's fine. But these conditions is actually the condition where we can detect with the if statement that the array is totally empty. The initial condition that he already give to us here in the previous code. Can you remember that condition? So
Yeah.
he reset the pointer to the initial condition that he defined when the queue is totally empty. So okay, that's fine to you? Does this make any sense to you?
Yeah.
Okay, good. So okay, I want to show you here. We off this. Now we have a look at the code here. So that is on the right hand side, I put the code for the linear array and also how it looks like the queue when for a linear array. And here I put for you how it looks like the front pointer and the end pointer in a circular queue. We said the circular queue is okay. Circular queue is going to maximize the use of every empty space inside the queue for insertion. So we said when you insert something inside the queue, the front pointer here is incremented by 1, right? Sorry. No, when you take out something out, I'm sorry. When you add to the end of the array, to the queue. You add at the bottom, right? But when you take something out, you take it from the front, which is this one. So when you take something out, this front pointer is incremented by 1. And that will be totally empty. You can add anything inside. Okay? But please, I mean, the way the code is written for the linear queue, it always check for one thing. If the end pointer or the queue, the tail pointer is pointing toward the end, it considers that the queue is full. No matter what, you have empty spaces here, it doesn't matter. He always look where is the end pointer queue or the tail pointer pointing to, and based on that if condition, he decide the queue is empty or not. So here he always, if it reach 7 or 10 in this case, he will say that, oh, it's full. So he will print that statement and he will not be able to insert anything. But now we want to use to redesign the code so that we don't look at the tail pointer anymore. We want to do something else. We want to change. The concept is new and slightly maybe not so easy from the first time to catch it. So I will not discuss that in full details in one shot. Okay, I want to discuss it on a few sessions to come, but I will give you just a brief now. So have a look at the code changes here. He used something different from before. Last time we don't have. Let me put that in. So this is the same function, but he used now queue length and rear pointer. It doesn't matter. Sometimes you call it tail pointer, rear pointer. It doesn't matter. Okay. But now he's using a few things that is different. He's talking about queue length and queue full. Queue full, it is the size of the queue. What is the size here? If you look at from 0 to 7, what is the length? What is the length of the array?
7?
No.
Oh, no.
8, right? So the Q full is equal 8. This is the Q full. What is the Q length? The Q length count how many. It counts how many data that is already inserted inside the queue. Can you look here how many data is inserted?
6? No.
Yes. See, yes, correct. Because he start again in the this is a circular queue. That's why you see that the front no need to be always on top, and the end pointer or the tail pointer no need to be always at the bottom, because it's a circular. So you know, so if you reach now here, the end pointer will be always in the linear. It will always stuck here. Once it reach here, it will stop and it will not move anywhere. This is the end pointer in the linear queue. Circular queue, no, it rotates. So once the end, the tail pointer reach the bottom, and if it has an empty space on top, then it will, the end queue will start to move on top. From here, it will start to point to the top. Okay, so now we are able to maximize the use of empty spaces inside the queue. So if the queue length, now in our case 6, which is less than 8, this means because there is 2 empty spaces here, right? So what will happen here? Please try to tell me what is this if condition is doing.
If the real pointer is less than the length of the queue, which is 8, then -1. And if the real pointer is equals to the if the real pointer if the real pointer is wait a moment. Sorry, so I have to readjust the screen. My screen cracked.
Oh, okay.
So there's a black spot. I can't see the. Okay, if the length is less than the queue.
So what is it? First, before you talk about the if statement, what is this? What is the output of that?
The queue of the length. I mean the length of the queue, which is 8.
It's 8, right? Okay. And when you subtract it -1, it becomes
7.
7. It becomes 7. You subtract 1 from 8 is 7.
Yeah, 7.
Okay. So now read the if condition again.
So if the real pointer is less than the length of
7.
The less than 7. Yeah.
Okay. What we're going to do?
The real pointer will be added by 1, so it goes down the array by 1 more.
Okay, so it means that if we are not reaching 7 yet, I will just add 1 to the real pointer. I will move, let's say it's, if it is, I mean, okay, now let us look here. If it is 0 and here is 7, so if the, assume that real pointer is here, real pointer is here. So if it is less than 7, I will just increment the real pointer to by 1. Right? Okay, good. If it is not, if it is at 7,
yeah, if it's at 7, then the rear pointer stays where it is.
No.
Oh, no. It resets to 0.
It's reset to 0. Where is 0? This is 0. So it means that if it is pointing to 7, no, it will come up again to point here.
Yeah.
But only on what condition? Only if the Q length is not full. This means that there is empty spaces in the array, right? Okay. So now, please tell me, what is that? What is this line?
If now the Q length is Q length. Now if the Q length,
what we said about the Q length, you counted here the Q length before, right? This is the real data inside the queue. It can tell us if the queue is full or not. Okay, now, so now in our case here, how many is the queue length now?
6.
6. Okay, and when you add 1 to it,
7.
Okay, and then what he's going to do here?
Q rear pointer. So the pointer points to the added item.
This specific line, he's adding something inside the queue. So he will put item inside the queue, but where exactly? What is the value of the rear pointer? We just incremented by 1 now.
The empty space. So 3 or 4.
Possible, or even 0. It depends on where exactly. So let's give an example. So if let me see. So if we have so okay, let's assume that there was nothing here. Let me see. I want to give you a real example. If we want to insert K, add pointer by 1, and so okay, item here equal K, and you have the value of the rear pointer is actually equal 1. Okay, so I want to tell it now. I want you to check this if condition again and tell me what is the result of that if condition. Now I give you real values now. So I'm telling you that rear pointer value equal 1. So it is pointing to here. Here, 1 is pointing to here. This is the rear pointer. So if I am pointing to 1, what is the result of this if statement? 1 is less than
6.
It is now length of the queue is what?
8.
Okay, minus 1?
7.
7. So rear pointer, if it is 1, is it less than 7 or no?
Yes.
Okay, so which we will run here, right? So what will be the result after this line?
It will be adding 1, so it becomes 2.
So okay, so it means that we will move the rear pointer from here. We will bring it here down.
Yep.
Okay, and then what is this going to do?
The length of the queue, the amount of data, will be added by 1.
Okay, and what about that?
The data, which is
K, in our case, here we said K. Okay.
Will be added to the.
Where exactly? Exactly. Okay. Okay. Now, okay, that's good. I will stop the enqueue here. I will not talk about anymore. I will talk about dequeue on the next session, but I want to discuss a few other things with you because I want to give you more ideas about many things that we can make your mind build the knowledge and build memory links. If we only talk about something in one session and then after 1 or 2 months, then you forget about it. We didn't do anything good. So I will stop here, and then I move to another topic.
Okay.
Okay. We need to move here fast. Okay. I want to talk today to you about sorting arrays. Okay. So we have two different algorithms for sorting an array. Okay. One called insertion sort, another called bubble sort. Okay. This is a slightly heavy topic, so we need to take our time to understand it properly. The code for that looks like this. Okay. I brought the two different algorithms here for comparison. Okay. But before we look at the algorithm and the real code, we need to really understand how it works. We need to look how it works. So both have different speed. It means that actually the bubble sort, when you add more, if you have an array that have a big amount of numbers, okay, then the bubble sort start to run slower than the insertion sort. Okay, so let's have a look here how this works. Okay, so you see here, bubble means it always, so let's have a look here. So imagine that you have this array at the initial point. Okay, we have, so when we sort an array, we put the lowest values on the top and the highest values at the bottom. Okay, and we say bubble because we run a few times of for loops, and these for loops, we run it, and okay, how to say, so for every element in the array we run a for loop. So if we have, how many elements we have here from 0 to 8?
9.
9. Okay, so if we have 9, it means that we have high possibility that we run, in the worst case scenario, we can run up to 9 times for loops to be able to arrange that array. But why I say worst case? Because sometimes the array is not fully unarranged. It means that, okay, like let's say, for example here 27 and 19, and then 36. So certain elements actually is already arranged and in the correct place. Like let's say, see this 36, it's never changed. Okay, so it means that you do need to really arrange that number 36 anymore. So there is one for loop that you no need to run. Actually, you can skip it. Okay, so now we're talking about general meanings first. So the first time you run the first for loop, you will find that, oh, you will compare 27 by 29, and then which one is smaller? The 19 is smaller, so you brought it up and you put the 27 down. Okay, and then you compare the 27 to 36. Which one is bigger? 26. 36 is bigger, so it remains where it is. There is no, so we have to stop here. We continue the next session.
Okay.